All right, so today we're talking about week 6 material, which is T distributions and T confidence intervals. And one of the new things that we're going to talk about is how we compute the actual critical value for T. So I want to explore a couple of tools that I do have. One of them is online, and that is the T distribution calculator Applet. So T distribution applet right there. And I'm going to send you this link in the chat. Give me one sec. And so you can see we do have this available. I'm going to show you how to use this. So I also want to show you in the TI 8384 calculator. So I'm going to pull this resource up. And we're going to use that resource. Excuse me. We're also going to use the Excel, because everybody has access to Excel, and then obviously the TI calculator. So I'm just going to open up the blank Excel. And I'm going to talk you through some basics. So in Excel, let me begin with Excel. Remember, the confidence intervals are always two-tailed. So if the confidence level is 99%, I'll do that one first. That means that alpha is 1%, right? So I should be doing this a little differently. So this will be, let's do this one. The confidence level. I'm going to put over here alpha. And over here, I'm going to talk about critical alpha. Okay, so I will send you this. I think this will be helpful to you. So let me remind myself that to send this to you. So I'm going to call sheet 1, which I will send you at the end of the class. I'm going to call this week 6 resource, and you can use it as you need. So actually, let's call the file week 6 resource. In this case, I'm just going to call this T distribution. T dist. We're also going to do T int with this as well. So let me write T dist, T int. It might actually not like this. T dist and T int. Okay, there's a reason I'm calling it both. So let's look at the 99% confidence interval. So we know that that means that alpha is 1%, right? Because that 100 minus 99 is 1. And our critical alpha in this case is equal to this value divided in 2, which is 0.005. Which means that the critical value that we're going to actually look up in this case is going to be 0.995. Remember, that's the result of adding the 0.99 and the 0.05. So actually, let me interpret this as 0.01 and not percent anymore. This is just going to be a regular number. So since it's already acting funny, I'm going to do that. So here I'm going to put 0.01, and this is 0.99. And then lastly, this is critical alpha, which is basically 1% divided by 2. So this is 0.005. Over here, this is going to be equal to that 0.99 plus. So you don't have to do this again. You'll just know how to put them together. So that's 0.995, and the opposite end, or its complement, would be 0.005. So FYI. So we're going to call this, take this off. So this will be the upper critical, meaning the positive side, and this will be the lower critical value. What I mean by that is remember what I said to you in response to whether confidence intervals, obviously they're two-tailed, right? So I'm looking at it this way. And so this would be my T lower, 0.005, upper would be 0.995. So in essence, the 0.995 or the 0.99 is actually in here, and this is the 0.01, which is 0.005 and also 0.005 on both ends. But when you look at it in terms of a z, it always goes from here out. So added together, that's why this is 0.995. Okay. Left alone from here back, this is simply 0.005. That's the idea behind of what I'm about to explain to you. Now, same thing applies to 0.95. So if I were to do the 0.95 here as a confidence level, that means that my alpha is 0.05, which means that my critical alpha is 0.025, which means that the upper critical value is simply going to be equal to 0.95 plus 0.025, which is 0.975. The other popular one that we know of is 0.90, which in this case means that this is 0.10, which means that this is equal to 0.05, which is basically this divided in 2, which I'll put in formula base. It's equal that divided by 2. And this value here is equal to the 90 plus the 0.05. So these are the critical values that you're going to see us using relative to the questions that we're going to do. Now, when we talk about t-distributions, as an example, let's say I'm looking at t inverse. Remember, with respect to the confidence interval in alpha, if I do equals t dot inv, for example, I'm going to double click on this little link right here. The probability, for example, if this is 0.90, let's use 0.90 because that's a good example. And let's say I had degree of freedom of 26, which I'm going to talk about in a minute. That would be my critical. Notice again that in the t inverse, this is not just a z-score or z value. This is a t dot inverse. You need the probability and you need the degree of freedom. So with that said, let's take a look at Aleks for a moment. Let me go here. I'm going to select aleks.com. All right, so today's work is week 6. So let me go back. Oh, I have to select the class. I forgot. Sorry. All right, so selecting your class, I'm going to go to reports, I'm going to go to assignments. And we're going to week 6. All right, so with week 6, we have t-distribution, which is what I want to talk to you about. So as an example, we're looking at this style of question. Let me open it up again. And notice that in this question it says, consider a t-distribution with 18 degrees of freedom. So we're looking at 18 degrees of freedom. So that means that we have a sample size of 19. So degree of freedom 18, and they want a t value greater than or equal to negative 1.57. In the second question, they're saying consider a t-distribution where we have 5 degrees of freedom, which means that our sample size is 6, because degrees of freedom is always n minus 1. So in this case, 6 minus 1 is 5. And they're saying that we're going to find p of negative c less than t less than c if this is equal to 0.99. And they want 3 decimal places in both questions. So let's explore this a moment. And notice that they're asking you in this case for p of t greater than or equal to negative 1.57. So you can obviously use your Aleks calculator because we do have that. They're giving us an actual t value. So understand in Excel, so in our case, we should get, as in this example, we should get 0.933 as our response with 18 degrees of freedom. So I'm going to show you, looking at this example, just to hone in on, we're going to use out the Excel. And okay, now you do notice in this question, this is the t inverse, and I'm using the area that's given to us. So that was that example. What if I change this, and I'm going to show you the connection in a minute, if this is equal to t.dist, and I double click on it. Notice it's asking for x, which is in our case the negative 1.57, comma. You do notice it's asking for degree of freedom, which they told you in the question is 18, comma. And we're going to select true to start. And if I select true, notice that I get 0.066. Okay, so I'm just going to remind you here that this is, first of all, let me click on it so you can see it again. This is t.dist. The x is the negative 1.57, 18, and true. That's what we put in there. So take a look at that, write it down. And I can give you a minute or two just to write it down, take it in the notes, and let's talk about this. So this is t.dist. So once again, it's going to ask you for the t value, so negative 1.57, the degrees of freedom, which is 18, and we hit true. Notice that that is going to be the complement of what I'm about to do next. So having that said, I'm going to go over here and actually all the way over here. And I'm going to go equal t.dist. We're not going to change it. T.dist, double click. I'm going to put in negative 1.57, comma, 18. Notice that did not change, comma, but this time I'm going to hit false. And see how I get 0.116246. Now, if I say that this equals 1 minus this answer, notice that we get 0.933087. This is our actual answer. On this side, I have the cumulative with everything else the same, but you notice that you get this value. That's because, let's see what happens here. If this equals this times this, I think in Excel that's what that reflects. I'm not sure. So no, that's not what that reflects. So we can actually disregard the t.cumulative. So we're going to focus on the true. This is the complement of this, and this is the upper side that we're looking for because it's greater than. And so that's how we get it. We simply subtract it. So that answers the first question. And again, if they tell me that the sample size in this case, as a review note, remember this is degree of freedom is 18, which means that sample size n minus 1 is equal to 18, which is your degree of freedom. So in this case, that means my sample size is 1 up 19. This is the t-distribution score, or t-value, they gave us. So knowing this, let's explore this with a couple of other resources, just for the moment, and I'll go back and we'll do it again and repeat. So let's use the TI-8384 calculator. What if I go second? And notice that I'm going to go to vars, second vars. And I want inverse t, number 4. Notice that it asked me for the area. So in this case, the area, if we assume it's a 90% confidence, so we're going to go with 0.90, we know the calculator is going to fix it. 18 degrees of freedom, and go ahead and paste it. You get 1.33. If I do second vars, given a question, and I look for inverse t, let's say I'm looking at 95% confidence, that's going to change the area 0.975, right? So we hope, with the same parameters given to our question, that's the answer. So if I have second vars, and this time I'm going to go to, let's go to inverse t. We can also do TCDF. I don't have the lower, so let's say 0. No, let's go 0.999. And 0.999 is just like a placeholder. And we put in our negative 1.57. Degree of freedom 18. Let's paste that. What does it say? Oh, I used a negative sign, that's why it doesn't like it. So negative vars, number 6, TCDF. I'm going to have to use this little integer. It doesn't like the negative sign, negative 1.57. Same thing, we're going to post this. And then obviously +1. Always correct that with a +1. It's like a no-brainer. And so this gives us another option where we're looking at this value in terms of high and low. We don't know the low, so we fill it in with 0.999. We do know the upper, which is negative 1.5718. All right. So these are just some tools that you have. We're not going to use this last example just yet. Did I just shut that down? Great. All right, let's do another example so we can fill our brains with lots of stuff. In the second example that they give you here in Aleks, let's take a look at that real quick. So we did the first one. Here we're going to look at this with the TI-83, by the way, not the TI-83, the Aleks. You actually see how it's set up here, where you have this. You have t greater than negative 1.57. So let's go back to that calculator for a moment, even though we're not going to use it. We're going to try to stick to Excel, and we're going to try to stick to the Aleks calculator, because I think those are probably the easier ones for you. So if I'm looking at the higher part of this, upper part, I'm going to go second vars, right? And again, I want to hit number 4, and we're going to put in the area. We're going to assume it's 0.995, or let's continue with 0.9. Degrees of freedom doesn't change, 18. And actually, that's not even what I need. My apologies. Yeah, I still get the 1.33. If I changed it, I would still get the 1.734 if I changed this to 0.95. I'm trying to find something else. Let's do TCDF again. That's this one. So this time I'm going to say the lower is the negative. Doesn't like that. Let me use this. Negative 1.57. The upper is what I don't know, so let's go 0.999. Let's do 2 more with 18 degrees of freedom. I'll show you what I'm actually doing is I'm looking to the right this time. When you do this, you get 0.7678. And if I would do 1 minus 0.76798, I get 0.3202. So yeah, it does verify it. That is the complement. But again, not going to be used. I don't even know why I'm talking about this yet, because we're going to use this eventually. But what you do want to focus on is, in using Excel, that you can actually find this simply by double-clicking on T.dist, putting in the negative 1.57, comma 18, comma true. And then when you obtain the value, remember that you're looking at the area above it, not behind it. So you just do 1 minus the previous value, and you end up here. So notice I have 1 minus the value in J24, which is 0.066913, which gives me that number. And this is what I want, because this is the area above negative, a t value of negative 1.57, if that helps. This is the area below the area of t equal negative 1.57. All right, so I hope that helps you for just visual purposes. And when you actually respond, when I send this to you, and I hope you can play with it. Okay, the second question that I have here, if you notice, it says, consider a t-distribution with 5 degrees of freedom. Remember, just as a review, if this is 5 degrees of freedom, then the sample size is 6, right? So you're going to find the value of the extremes, the extreme t values. That's what you're looking for here, if this is 0.99. So just as an example, just to show you the Aleks explanation here, remember this is two-tailed, so that means that alpha is 0.01, as you see there. We obviously have to split alpha into 0.005. So if you notice, we're going to look up t inverse 0.005, and you notice you get 4.032. So in Excel, or even using your TI-83 calculator, or your Aleks calculator, we're going to go to equals t dot inverse, double click on that. So for probability, we're going to put 0.005, comma, and they said 5 degrees of freedom for this question. Enter. See how you get the negative 4.03214? And if I repeat the same thing, equals t dot inverse, double click. Again, in this case, you're going to put 0.995, comma 5 degrees of freedom, and there you get the positive. So if you compare the two sets of notes, you can see why and where they're obtaining these values. So let me bring this over a little bit. So there's your negative and positive, and all I believe you need to answer in that case is where C is 4.032. Remember, they only want 3 decimal places, so we're going to fix that, right? By just using the shortening device. It shortens your decimals a little bit, right? So that's what we want to do. There you go. So again, all I did for that question was t dot inverse is what you want to use. Okay. So if you feel comfortable with this one, let's look at another example. Go here, I'll open this up. And your Aleks calculator is obviously very transparent in the examples. I don't know if you noticed, when you open up the explanation here, for example, if you notice this notation right here tells you that you should be using the calculator that looks like this. It's in your resources. It should have a T with a little box underneath it. That's one of your calculators. The other one that you want to use, let's see if they have a shorter version of that, is this one, where you really only need to look one of these up at a time. You're going to use this P of t greater than 1.22 with degree of freedom at 8. So let's take a look at this from scratch. So yeah, that you need that calculator. The second calculator is just beneath the t with a little 0 on the bottom. So it says consider a t distribution with 8 degrees of freedom, and you have t less than or equal to 1.22. And so that's the question. So you want to use that calculator. So I'm going to do that one first. We'll call that example A, and then example B, we're going to consider a t distribution with 28 degrees of freedom and an area of 0.99. Okay, and so we know in this case we're going to apply the same process. So let's do this on the calculator again, going back to basics. So using that little P of t calculator, you should be able to throw that in there and obtain your answer. So we want P of t greater than, less than or equal to 1.22. All right, so let's play with the calculator. So this one we would go with equals t dot dist, double click on it, and so it asks for x. X in our case is 1.22, which is the t value given to us. Our degree of freedom is 8 given to us, and the cumulative we want to select true. Now notice in the question this is representing P of t less than or equal to 1.22. All right. So if I hit enter on the Excel, notice that I obtain this value here. So you're given the t value, and this is the probability or percentage or area, however you're talking about this, that represents. If I want its complement, so if I want to do P of t greater than or equal to 1.22, notice that I'm simply going to do equals either 1 minus that answer, that's a possibility, or you can do equals t dot dist, double click on it, and again you're going to put in 1.22 comma 15 comma, and what if this time I do false? Let's see what we get. You get 1.84068. So you don't want that. You don't want false ever. We always want to subtract from the true. So it's always 1 minus true. So note to self, which we've discussed, is only use true as a conclusion, which looks like this. When I double click on it, that's what you're putting in, and that's because it's behind. If you want the area that's above it, then this is your answer. You simply do 1 minus that. Okay, and remember, I'm going to send this to you so you'll feel confident. Now, let's look at the next question real quick. In this next question, it says, consider a t-distribution with 28 degrees of freedom, and then find the area such that we get both sides of the interval. It's obviously two-tailed is what they're implying. And this is 0.99. So we want to use, again, t dot inverse. So that one you want to use the calculator that has the little box. So go to your calculator section in Aleks, and we want the one with the box. it's going to be ask you for probability. So remember, there's the 0.005, so 0.005, comma, and then it asks you for degree of freedom, 28. So if I go to Excel instead and I say equals t dot inverse, double click on it. Again, the probability is 0.005, comma, and our degree of freedom is 28. So that gives me the negative part of it, but according to this, we want t is less than. So if I want that, then I'm going to go equals t dot inverse you're going to put in 0.995, comma, and there's your answer, 2.763. So you need to pay attention to the direction given to you in the question. So in this question, this is P of t less than or equal to 1.22 with degree of freedom. I'm sorry, this is not the question. This is the previous question. This one you're going to use t and with the little box underneath. And so we're going to use 0.995, comma, 28. Sorry, I had a moment. Okay. And so that is the gist of this. Again, if you're using the TI-8384 calculator, which I do want to talk. Oh, you know what I haven't talked to you about is this. Let's play with this applet and let's see what happens. So what is the X? What is a T? And this we're going to figure out. So they do give you a help explanation there. That looks confusing. So it says here in the value for X, and let's use one of the questions that we have finished. So in our case, what if we do, let's do the negative 1.57, which I believe we explored that one. And let me see, I believe that they're giving us 18 for the degrees of freedom. I believe that's this. Let's see what we get. Our question was greater than or equal to, so according to that, that's 1. I don't know what I feel about this question. Hold on. 1, 0. Okay, I'm not feeling this one. If degree of freedom is 18, let's see if that changes if I swap these. And X is negative 1.57. Yeah, I believe this is it right here. Pay attention to this one. That should help you. So I'm using the first example. The X value will be used as your T value in this applet. I actually found this by chance for the first time today, so I'm glad I'm able to share it with you. Notice that the V is your degree of freedom. So that's nice. What I like about this is you do have a in between, like if you have a two-tail, like the example here. So I believe for this one, our degree of freedom was 5, and the X value that they gave us, they actually gave us the area. So let's try this, 0.99 here. You click on it, you do get the value. Notice that this is the T value, 4.032. So here's what I am asking you now is, as I have explored Excel and the TI-83 calculator for this, you can do the same now using these tools. Again, I'm sending you this URL. I'm going to pop it in here. And see if I can paste it. If I can't, I'll send it to you via email as well. but it's a very helpful little tool. Okay, which one else did we do? We did the next example where we had 28 degrees of freedom. Let's change that to 28. This is like our third example. And our area that we have for this one is also 0.99. See how you get 2.763, and that's your answer. So this should help you with your homework as you're doing the homework. All right, I'm going to pause this part of the video here, and give me 1 second to do that. And then we're going to start with, so let me just pause it for a moment. And then I'm going to go ahead and record the second part where we're going to talk about sample size. I'm actually going to skip the second part, which is the distribution where we actually do the confidence interval. I'm going to talk to you about sample size because that's a pretty quick concept. Bear with me for a second.